Hello folks, I am Ed Overstreet and I'm back with, it's not necessarily a part two, but I wanted to clarify some things that I thought were even confusing when I watched the video I did on the Spectrophotometric Color Calibration Tool. So let's head over to PixInsight and clear some of those things up. Okay, if you have the latest version of PixInsight, and if you don't, that update is needed in order to have access to the new spectrophotometric tool. But you can find out by going to About on a Mac and no, hang on, About PixInsight, and then you'll have, I have, the latest update is 1.8.9-1. So you need the 1.8.9-1 update. Having a hard time. Okay, and if you do, if you go to process, all processes, and come down to the spectrophotometric color calibration, I would imagine that there will not be a photometric calibration tool any longer, that this will replace it. One of the things you'll notice about this that makes it different than photometric calibration is that plate solving is going to be done internally. You do not have to either manually add RA and DEC or search different databases or install the APAS catalogs so that you can have a quicker access to plate solving your image. You no longer will be doing that. That's going to be part of this photometric calibration spectrometry. But what you have to do is you either have to run the weighted batch processing, the new weighted batch processing script, or you're going to have to run Image Solver. And if you don't use the WBPP script, then if you go to, I think I can, script, image analysis, you can go down to Image Solver and you can open this up. And if you have an active window and image here, then you can search and see if you can't find the right RA and DEC information, and then you'll click OK, which will apply that to your image, and then the spectrophotometric color calibration can read it. But make life easy for yourself. Make sure when you're going through the process of calibrating, registering, and integrating, debayering your images, that you just go ahead and buy into the weighted batch processing script. Now, I'm going to open that up to point out something that's important in this use of this new tool. I think I'm going to open it up. All right. When you run this tool, it's stressed that you do two things. One, on a one-shot color camera, that you have an IR UV cut filter for more accurate color rendering. So the filter that will give the greatest color rendering, according to the documentation in PixInsight, is an IR UV cut filter, number one. And then number two, they stress that you drizzle your images. Now, drizzling, from my perspective, was necessary because several of my combinations of camera and telescope created a very undersampled image. And so I drizzled to upsample. And it's a awesome technique that PixInsight employs. The algorithm they use for that upsampling is spectacular. But if you have an image that doesn't need upsampling, then it is recommended you still drizzle. But you don't have to drizzle times 2. In other words, you don't have to double the image size and ultimately double the processing time for each step. If your sampling is is spot on, then just drizzle one time. And you do that in post calibration. Just click on an image or a set of frames and go to enable. And if you're going to just drizzle one time, which means you effectively do not change the image size, this means that your sampling is spot on, then just leave it at, or put it on 1 and then apply to all of your groups. And you have 2 groups here. In my case, I have 2 groups because I shot 240-second images of the same target that I shot 120-second exposures, not images. 240-second exposures and 120-second. I wanted to compare the two. Anyway, so, and then you apply this to all groups. So this is where you drizzle. And back at calibration, you're not going to be able to drizzle if you choose anything other than VNG. There's a good reason to choose superpixel, especially if you want to separate your RG and B channel. But in this case, if you're going to drizzle, if you have a one-shot color camera, then make sure you have VNG as the Bayer method. And this does a lot of interpolation, but this is what you'll need to use, and then drizzle 1. So important. And of course, run the weighted batch processing script. That goes without saying. All right. Now, you're going to have to get this catalog, the Gaia DR3/SP catalog. And you're going to have to install the catalogs. So how do you do that? Well, let's find them first. If you go to the PixInsight website, then go under software distribution. This is where you downloaded PixInsight in the first place. You're going to see that you have your APAS catalog files and your Gaia DR3s. Here's what you want. You either want this one or this one. I downloaded the small set. The documentation that PixInsight has provided with this script suggests that this should cover every target that I will ever image in the night sky. But if you want the complete set, just make sure you have the drive space available, download it. So when you go to this set, then you'll grab all 3 of these, just click on them and they will download. Make sure you select a folder to download those in, because you're going to have to go fetch them in just a minute. You don't need checksums, but just download these 4 catalogs. Yeah, 4 catalogs. If you want the complete set, then you have a few more catalogs to download. And again, you can see that they're going to take 3 gigabytes per catalog. So I've got the small set, and that worked just fine so far. If I see that I am getting fails, then I may try downloading the complete set. I'm also going to put a link on this YouTube channel to the documentation. And I've gone through everything. Some of it I don't understand, and I'll tell you where I lose it, where it loses me. The very minute that we go to the star detection point spread function fitting, the mathematics, I can't follow it. And it was not my strength. I'm a football coach, retired. And I'm not going to ever have an opportunity to explain how this point spread function flux evaluation is formalized. So anyway, but right here are going to be 3 parts or 3 areas of documentation that you should read and you will understand. For monochrome cameras, And for the one-shot color camera that we're doing now, by the way, it's where it says we strongly recommend using a camera system that rejects ultraviolet and infrared light. And this can be done using an IR UV cut filter. So number one, and then down here it says another point when working with when one-shot color cameras is to always use drizzle. So it's from this that the stress is made, and I just parrot that. So once you've downloaded these catalogs, then you're going to need, back to PixInsight, then you're going to need to load those catalogs in the Gaia process. Now, you can do that by going up to Processes, uh, All Processes, and go over here to, no, go here, go to Process Astrometry, ah, too fast, and click on Gaia. Or you can go over here to Process Explorer. And if you don't have Process Explorer, you can go up here to View, Explorer Windows, and then click on Process Explorer, and it will load it on this bar over here. So do your Process Explorer, and then scroll down here to Star Catalogs. And then double click on Gaia, and this will come up. So what you now have to do is load the new catalogs. So click on the wrench and then find the catalogs now that you now have. You'll have to go retrieve them and just put on select, and it will take you to your file system, and then navigate to the folder where you stored them. Select the folder and the files, and load them up. And now you have the DR3 files in your accessed in your spectrophotometric calibration process. You can close that out, and you're pretty much done, with the exception of one change. I was looking at a couple of the templates that PixInsight used, and I noticed that they both had a growth factor of 2.0. I'm not sure why, and when you hover over these, sometimes it gives you an explanation. The growth until now, it just didn't come up. So there is an answer for it. I'm not going to read it. You can take some time to read it. But I went ahead, since both of their templates had the growth factor set to 2, and it defaults to much less than that, like 1.25. I went ahead and changed mine to 2, and I saved this process. Okay, the next thing you want to do is leave average spiral galaxy alone. This has nothing to do with your target. You could have a nebula, a cluster, or galaxy. It's just that if you go through the documentation, you're going to read where the use of an average spiral galaxy inculcates all of the colors. And so they're using that as somewhat of a reference for color calibration. It also states that you want to leave the ideal quantum efficiency curve to default. This is what you want to have up. Don't change. Now, I use ZWO cameras, and so if you do, then you have a Sony sensor. So if you click on, by the way, here are cameras that are sensors that are the most common, but I'll go down here to Sony, and the R comes up because I'm in the red filter, and I just clicked on that. I don't have I did not take this image with an IR UV cut filter, so I want to make sure I clear that up. So I've got the green, and then down here I have the blue. So this is what I currently have. Now I'm going to bring up everything else. I'm going to leave to default. Oh, one other thing. I'm going to bring up an image that we're going to run the script on, and let's see. I'll bring up the, okay. I'm going to bring up two images. I'm going to bring up this auto crop, which is new in the new latest PixInsight update. And what PixInsight has done, it has automatically cropped my image to get rid of the stacking artifacts. So if you open, I'm not going to do it. I'm going to get right back to photometric calibration, but I encourage you to do this. The next time you run the weighted batch processing script with the newest 1.8.9 version, open both of these and check the crop. And you'll notice they have cropped out the stacking artifacts for you. You don't have to do it. So I'm going to open this. Saves me a step. And please understand, it's going to be easier to plate solve an image that doesn't have stacking artifacts. And if you look right here, I don't think you can see it, but this is the, I'm not even sure if this is a rejection folder or not, but this shows the auto crop mask. And you can see a fine line going around here where the cropping took place. And so that is what has happened. And I just think that's brilliant that they're doing that. So you don't need to keep it. You can delete it. When you stretch your image, you're going to see that it's all gone. Now I'm going to go ahead and bring up the screen transfer function. So you'll be able to see the effects of color calibration. Oh no, I've lost my mind, guys. Screen transfer function, not the new script. It's already open. So I'm going to unclick the channels and restretch because I want you to see the effects of color calibration. Now, you do have one responsibility, and that is to create a background that can be used for background neutralization. So I'm going to zoom into my image, and I'm going to create a background right here. You don't really want any stars in it, and just a clean background. And then I'm going to find that. I'm going to go to region of interest from preview, and I'm going to click this preview. Now I haven't tried running this with the background neutralization unchecked, but because when I'm processing, the very first thing that I do out from the time I crop the image is I run background neutralization, and then I usually do DBE. So in this case, I'm going to perform it here. I'm going to run it here, and then the Spectrophotometric Tool will be able to use that. So I'm essentially done. Let's run it and see what happens. And I'm not going to pause this. I have a slow Mac, guys. This is a 2015 iMac, and so I do have 32 gig of RAM. That's the only really modification I made to it. But I'm going to go ahead and just let this run so you can see an idea of how quick this thing is really working. And it's brilliant. Thank you, PixInsight, and the developers for having done this. It's done. Now, I'm over my head here again. The formulas don't make sense to me, and that's okay. But here are here's the points where I guess the this particular camera throws the pixels or the color. I just don't know really what this is. I don't know what this is, but I'm hoping it's okay. And compare yours with mine, and I don't even know what a good baseline would look like. But I'm sure sooner or later, Adam Block or Warren Keller, somebody will come out explaining this, and I'll be in tune to that when that happens. So it's done. It has performed brilliantly. I am going to go ahead and click it, and I now have a color calibrated image using the new Spectrophotometric Color Calibration Tool. I'm going to save this process, and I just saved it. I already have done this, but I saved it, and I call this one-shot color camera. And then I also use astronomic filters. I'm going to go ahead and create an icon for that. So here's the astronomic deep sky filter for red. This was the green channel. Here would be the for green, and here would be for blue. Whoop. Already did green. Let's do blue and deep sky. If you have other narrowband filters, or if you have narrowband filters that aren't included, you can click here, and then you can add the wavelength and bandwidth. I have some 6 nanometer filters, and I can research from the website the bandwidth and our wavelength, and I can add that there manually and optimize for stars. So folks, that's pretty much what I should have said when I did the other video. And I'm sorry I'm putting you through 2 of these, but hopefully this will help get you up and running. Y'all have a great day, clear skies, and I'll catch you on the next go around.